Hi everyone, Miss Andronicus here, and today we are looking at describing transformations. A transformation changes an object, which is the original shape, into an image, the final shape. And so you have already looked at reflection, rotation, translation, and enlargement. Okay, so translation is when we slide that object to become the image, left and right, up and down. Reflection over a mirror line. Rotation is always around a point, either clockwise or anti-clockwise, and enlargement is when that object gets larger. Okay. The image stays congruent in translation, reflection, and rotation, and it's similar when enlarging. So, of course, when you're enlarging, everything needs to be in proportion in regards to that enlargement, so that there is a scale that you're following. Every side, let's say, gets enlarged, multiplied by 2, for example. When we're describing transformations today, we are going to focus on the first 3, translation, reflection, and rotation. So starting with reflection, when we describe transformations, you need to give a complete and full description of each one. So with reflection, if we have a look at this example here on the right, we need to give a full description of the mirror line. Often, usually is the equation of the line on the graph. So if we have a look here at this Cartesian plane, if the original is black and the image is the green, we can see the reflection is over y equals 0. So it's the line that cuts that y-axis. So it cuts the axis at 0, that's where you would draw the line, and that's where the reflection is. If it was, let's say, one box up, and the line would need to be drawn here where it cuts the y-axis at 1, then it would be y equals 1. If it was reflected the other direction, let's say that way, then we would need the line that cuts the x-axis, and we would say x equals whatever. Okay, so that's how you would describe that particular reflection on that Cartesian plane. When it comes to rotation, we need to give a little bit more information. So the center of rotation, given often as coordinates, the angle of rotation in degrees or fractions of a turn, it's most likely degrees, and the direction. Of course, if it's 180 degrees, then you just have to say 180 degrees and you don't need the direction, because any direction still gets you to the same point. So have a look at this example. The center of rotation's actually been given to you. It doesn't always, it's not always given to you. In this case it is, and they've drawn it there at the origin. We would say that is 0.00, that's your coordinate for that point. So this image has rotated 90 degrees anti-clockwise around 0.00. And you can check that when you are coming up with this rotation and how, in fact, it has been rotated. You can have a look at this. So if you, let's say, I want to go across and then I want to go up to this point, okay, I can draw that connection. In this case, it would go down and across to get to that same point. So if I have a look, what angle has that particular track taken? It has taken a 90-degree turn, and I can see the direction is anti-clockwise. I can see the point of rotation is 0, 0. Okay, translation, a full description of how far it's moved, up or down, left or right. So for these directions, you can use a vector. Okay, so that's where you've got those two numbers stacked, such as this example. For a vector, this is the top number. Describing the translation, the top number is whether you are going left or right. Okay, so if the top number is positive, then the translation's going right. If the top number is negative, then the translation is going left. For the bottom number, if it's positive, that means it's going up, and if it's negative, it's going down. So in this example, I look at the top number, that's my left or right, it's positive, so I know it's going right. And that bottom number is negative, it's the up or down, so that means in this example, it would be going down because it's negative. Okay, so let's have a look at this example. Okay, the object has been translated 4 to the right and 2 up. Yes, I can check that. 1, 2, 3, 4, and then 1, 2, because I can choose a point. Yes, it's gone 4 to the right and 2 up. That would be one answer. As a vector, though, the object has been translated 4 to the right because it's positive, so it has to be positive 4, and 2 up because it needs to be positive, so then it's a positive 2. If it asks for an inverse translation, it's essentially from the image to the original object again. It's basically that translation backwards. So if I was going down 2, then it's a negative, and I would be going left 4, it's a negative. Okay, so just keep that in mind with translations, and we will cover describing enlargements in another video. Thanks guys, bye.